There was a moment in construction history when job sites changed forever. Not because of computers, not because of automation, but because machines became unstoppable. The 1970s unleashed a generation of earth-moving equipment so powerful, so reliable, that entire construction methods had to be rewritten. Projects grew bigger, deadlines became shorter, and human limits were replaced by mechanical muscle. These machines didn't just move dirt. They transformed how roads, dams, cities, and megaprojects were built. Today, we're counting down the 10 earth-moving machines from the 19th that changed job sites forever. The iron giants that laid the foundation for modern construction. Get ready, because once these machines arrived, there was no going back. Number 1. Caterpillar D9G Bulldozer. The Caterpillar D9G Bulldozer was not just another upgrade in Caterpillar's lineup. It was a machine that fundamentally redefined what heavy earth-moving meant on a job site. Introduced in the early 1970s, the D9G arrived at a time when construction projects were becoming larger, tougher, and more ambitious. Highways were being carved through rock, mines were expanding rapidly, and large-scale land clearing was becoming routine. Smaller dozers simply couldn't keep up, and the D9G filled that gap with overwhelming force. What made the D9G revolutionary was its sheer mass and power. Weighing tens of tons and powered by a large Caterpillar diesel engine tuned for relentless torque, the D9G could push enormous volumes of material in a single pass. This dramatically reduced the number of machines required on site. Tasks that once needed multiple mid-sized dozers working in shifts could now be handled by one D9G, cutting project timelines and labor costs significantly. Its heavy blade allowed it to move dense soil, rock, and debris that would stop lighter machines dead. The D9G also changed how job sites were planned. Contractors began designing projects around the capabilities of these massive dozers, knowing they could rely on consistent, predictable performance. The machine's mechanical transmission and oversized final drives were designed to survive continuous shock loads, especially in ripping and rock-pushing applications. This reliability allowed the D9G to work long hours without frequent breakdowns, a critical advantage on remote job sites. Perhaps most importantly, the D9G set a new industry benchmark. Its layout, durability, and raw power influenced the design of every large bulldozer that followed. Many D9Gs remained in service for decades, often rebuilt multiple times. Their longevity proved that over-engineering was not wasteful, it was essential. The D9G didn't just move earth, it changed expectations of what a bulldozer could do. Number 2. Komatsu D355A Bulldozer. The Komatsu D355A bulldozer marked a turning point, not only for Komatsu, but for the entire earth-moving industry. Introduced in the 1970s, the D355A was the machine that forced global contractors to acknowledge that Caterpillar was no longer the only name capable of building truly heavy-duty dozers. Until then, Caterpillar dominated large-scale earth-moving almost uncontested. The D355A changed that balance overnight. Built for mining, dam construction, and massive infrastructure projects, the D355A was enormous by the standards of its time. Its frame was heavily reinforced, its undercarriage oversized, and its diesel engine designed for continuous operation under extreme loads. Komatsu engineers focused on durability first, knowing that their reputation depended on surviving the harshest job sites. The result was a bulldozer that could push huge volumes of material day after day with minimal downtime. On job sites, the D355A transformed productivity. Contractors could now tackle larger cuts and fills with fewer machines, simplifying logistics and reducing maintenance complexity. The machine's power allowed it to rip and push material that previously required drilling, blasting, or multiple passes with smaller equipment. This fundamentally changed project planning, especially in mining and large-scale civil works. The success of the D355A also had a broader impact. It forced competitors to rethink their designs, leading to a new generation of larger, more powerful bulldozers across the industry. Komatsu's rise as a global heavy equipment powerhouse can be traced directly back to this machine. Even today, the D355A is remembered as the bulldozer that proved toughness, not brand loyalty, wins on the job site. Number 3. Caterpillar 992 wheel loader. Before the Caterpillar 992 arrived in the 1970s, wheel loaders were often viewed as support machines, useful but rarely the centerpiece of production. The 992 changed that perception completely. It was one of the first wheel loaders designed to operate at the heart of high-volume material handling, especially in mining and large quarry operations. The key innovation of the 992 was scale, combined with durability. Its massive bucket capacity allowed it to load haul trucks in fewer passes, drastically reducing cycle times. On busy job sites, this translated directly into higher productivity and lower operating costs. The loader's powerful drivetrain and reinforced articulation joint allowed it to handle dense rock and heavy aggregate without structural failure, something earlier loaders struggled with. The 992 also reshaped job site logistics. Faster loading meant trucks spent less time waiting, improving overall fleet efficiency. This allowed contractors to optimize haul routes, reduce idle time, and move more material with the same number of machines. In mining operations, the 992 became a critical link between extraction and transport. Durability was another defining factor. Caterpillar built the 992 to run continuously in punishing environments: dust, heat, vibration, and constant heavy loads. Many units remained in service for decades, often rebuilt multiple times. The machine's success set the standard for large wheel loaders worldwide. Modern mining loaders still follow the basic layout and philosophy established by the 992, proving that this 1970s machine permanently changed how job sites handled material. Number 4. Euclid R50 haul truck. The Euclid R50 haul truck was one of the machines that truly unlocked mass earth moving on a scale never seen before. Introduced in the 1970s, the R50 allowed contractors to move enormous volumes of material across job sites efficiently, eliminating the need for rail systems or complex conveyor networks. This flexibility fundamentally changed how large earth-moving projects were designed and executed. The R50 featured a rigid frame design built from heavy steel, capable of carrying extreme payloads over rough, uneven terrain. Its powerful diesel engine and robust drivetrain allowed it to climb grades while fully loaded, something earlier trucks struggled to do reliably. Suspension systems were engineered to absorb constant shock, enabling continuous operation in mines and large construction sites. On job sites, the R50 changed everything. Instead of being limited by fixed material transport systems, contractors could now redesign workflows around mobile hauling fleets. Cuts, fills, and dumps could be repositioned as projects evolved, saving time and money. The concept of large-scale haul roads became central to project planning, a practice that continues today. The influence of the Euclid R50 is still visible in modern haul trucks. Its success proved that massive mobile hauling was not only possible but superior for many applications. By enabling flexible, high-volume earth transport, the R50 helped shape the modern construction and mining job site as we know it. Number 5. Caterpillar 225 hydraulic excavator. The Caterpillar 225 hydraulic excavator represents one of the most important technological shifts in earth-moving history. When it entered job sites in the 1970s, it didn't just introduce a new model, it signaled the beginning of the end for cable-operated excavators that had dominated construction for decades. Until this point, excavation relied on slow, mechanically complex cable systems that required skilled crews and constant adjustment. The CAT 225 changed everything by proving that hydraulics were not only viable but vastly superior. The biggest impact of the 225 was precision. Hydraulic cylinders allowed operators to control boom, stick, and bucket movements smoothly and independently. This meant faster digging cycles, cleaner cuts, and far more accurate trenching. Tasks that once required multiple machines or extensive manual cleanup could now be handled by a single excavator. Job sites became more efficient almost overnight. The Caterpillar 225 also changed workforce dynamics. Cable excavators often needed crews of helpers, mechanics, and riggers to stay operational. The 225 could be operated and maintained by far fewer people, reducing labor costs and simplifying logistics. Contractors could now move machines quickly between sites and adapt to changing project needs. Durability played a major role in its success. Caterpillar built the 225 with a heavy steel structure, robust swing mechanism, and conservative hydraulic pressures. These machines ran in dust, heat, and mud without the electronic vulnerabilities of modern equipment. Many Cat 225 excavators remained in service for decades, especially in developing regions. Most importantly, the 225 changed industry direction. Within a few years, hydraulic excavators became the global standard. Cable machines disappeared from job sites almost entirely. The Cat 225 didn't just improve excavation, it rewrote how earth-moving was done. Number 6. Hitachi UH083 Excavator. The Hitachi UH083 excavator was a quiet revolution in the 1970s, proving that earth-moving productivity didn't always require massive machines. At a time when bigger was often equated with better, the UH083 showed contractors that compact, efficient hydraulic excavators could outperform older, bulkier cable machines in many applications. The UH083 excelled in urban construction, utility installation, and confined job sites where large equipment was impractical. Its smooth hydraulic system allowed precise control, making it ideal for trenching, foundation work, and detailed grading. This versatility fundamentally changed how contractors approached mixed-use job sites, where space and adaptability mattered more than raw size. Reliability was a key factor in the UH083's impact. Hitachi engineered the machine with a strong steel structure, dependable hydraulics, and a diesel engine designed for long service intervals. Operators quickly learned that the UH083 could work long shifts with minimal downtime. Its simplicity made it easy to maintain, even in regions with limited technical support. The success of the UH083 also had industry-wide consequences. It helped establish Japanese manufacturers as leaders in hydraulic technology, challenging established Western brands. More importantly, it influenced job site planning. Contractors began deploying fleets of specialized machines, small, medium, and large, rather than relying on one oversized excavator for every task. Today's mid-size excavators owe much of their design philosophy to machines like the UH083. It proved that precision, reliability, and flexibility could change job sites just as dramatically as brute force. Number 7. Caterpillar 631 Motor Scraper. The Caterpillar 631 motor scraper was one of the most transformative earth-moving machines of the 1970s because it fundamentally changed how large-scale grading projects were executed. Before scrapers like the 631, moving large volumes of earth required multiple machines: dozers to cut, loaders to load, trucks to haul, and graders to finish. The 631 combined many of these functions into a single, highly efficient unit. The genius of the 631 was integration. Its bowl could cut into soil, load itself, haul material over medium distances, and then spread it evenly at the dump site. This reduced the need for additional equipment and operators, dramatically lowering project costs. On road construction, airport runways, and massive embankments, scraper fleets became the backbone of operations. The 631 also changed job site rhythm. Instead of stop-and-go loading cycles, scrapers created a continuous flow of material. This allowed projects to progress faster and more predictably. Contractors could schedule work with greater confidence, knowing scraper production rates were consistent, built for punishment. The 631 featured a heavy frame, powerful engine, and rugged driveline designed to handle constant loading shocks. These machines operated in heat, dust, and mud for years with minimal downtime. Many were rebuilt multiple times, extending their service life far beyond expectations. Even today, modern earth-moving projects still rely on the scraper concept pioneered by machines like the 631. It changed job sites by proving that efficiency comes from integration, not just power. Number 8. Volvo BM A25 Articulated Hauler. The Volvo BM A25 articulated hauler changed job sites not by being the biggest machine, but by going where others couldn't. Introduced in the 1970s, the A25 pioneered the articulated dump truck concept, allowing contractors to move large volumes of material through soft ground, steep slopes, and uneven terrain that rigid trucks simply couldn't handle. Before articulated haulers, earth moving was often limited by ground conditions. Mud, snow, or loose soil could halt operations entirely. The A25's articulated joint and all-wheel drive allowed it to maintain traction in conditions that would immobilize conventional trucks. This opened up new project possibilities in forestry, dam construction, pipeline work, and remote infrastructure. The A25 also improved job site safety and efficiency. Its ability to follow uneven ground reduced the risk of rollovers, while its mobility minimized the need for extensive road preparation. Contractors could begin earth moving earlier in a project, saving time and money. Built with Volvo's reputation for durability, the A25 featured a strong frame, reliable drivetrain, and simple mechanical systems. Many units remained in service for decades, especially in harsh climates. The articulated hauler concept pioneered by the A25 is now standard worldwide. Modern ADTs still follow the same basic design, proving that this 1970s machine permanently expanded the boundaries of earth-moving job sites. Number 9. John Deere 644 Wheel Loader. The John Deere 644 wheel loader from the 1970s may not have been the largest machine on a job site, but it was one of the most influential. At a time when many construction projects relied on specialized machines for each task, the 644 demonstrated the power of versatility. It could load trucks, move stockpiles, backfill trenches, handle aggregate, and support road construction, all with a single durable platform. This flexibility fundamentally changed how contractors organized daily operations. What made the 644 so impactful was its balance of power, size, and reliability. Powered by a robust diesel engine tuned for steady torque rather than peak output, the machine could work long shifts without overheating or excessive wear. Its drivetrain and axles were built to handle constant forward-reverse cycles, a punishing duty cycle common in loading work. Many competitors struggled with this type of repetitive stress, but the 644 thrived under it. Structurally, the 644 featured a strong articulated frame and a well-designed loader linkage that could handle heavy buckets without fatigue cracking. The articulation joint was reinforced to survive years of twisting under load, and Deere's conservative engineering approach meant components were rarely operating at their limits. Maintenance was straightforward, allowing contractors to keep machines running with minimal downtime. On job sites, the impact of the 644 was clear. Contractors began relying on fewer machines to perform more tasks, reducing fleet size and labor requirements. This shift toward multi-role machines improved efficiency and flexibility, especially on medium-sized projects. The John Deere 644 helped establish the wheel loader as a central job site tool rather than a supporting player, a role it still holds today. Number 10. Bucyrus-Erie 195 Electric Shovel. The Bucyrus-Erie 195P electric shovel was not just an earth-moving machine. It was a declaration that the limits of job site scale had been permanently shattered. Introduced and widely used during the 1970s, the 195P represented the extreme end of earth-moving capability, particularly in mining. With a bucket capacity that dwarfed conventional excavators, it could move more material in a single cycle than smaller machines could in minutes. The 195B changed job sites by enabling operations on a truly massive scale. Open-pit mines expanded rapidly because machines like this could remove overburden and load haul trucks at unprecedented rates. Entire project layouts were designed around the shovel's position, swing radius, and loading capacity. Instead of many small machines working together, one giant shovel could dominate production. The machine's electric power system was also revolutionary. Unlike diesel equipment, the 195D delivered constant, reliable power without the limitations of fuel logistics. Its massive steel structure, industrial-grade swing mechanisms, and heavy-duty components were designed for decades of continuous operation. Many units worked for 30, 40, or even 50 years, undergoing rebuilds but never truly being replaced. The influence of the 195B extends far beyond mining. It changed perceptions of what machines could accomplish and pushed manufacturers to think bigger. Modern mega excavators and shovels trace their lineage directly back to this era. The Bucyrus-Erie 195B didn't just move earth, it redefined the upper limits of human-engineered power on job sites. Those were the machines that redefined construction. Built in an era when durability mattered more than efficiency, And strength mattered more than comfort. They pushed limits, shattered expectations, and turned impossible projects into reality. Even today, their influence is visible on every major job site around the world. Which one of these 70s earth-moving legends impressed you the most? Tell me in the comments. I read every one. If you love heavy machinery history and unstoppable engineering, hit like, subscribe, and share this video with someone who respects real iron. Thanks for watching. And until next time, keep moving Earth and keeping the legends alive.